Characteristics of linear functions, that's the one we should be on, that's the page. As you can see from the objective, there's quite a bit that we're going to get through. It says students will be identifying characteristics of linear functions, describe the effects of parameter changes on that parent function, determine the equation of a line from given information. Students will also analyze problem situations and collect data by representing the situation with a table, a graph, verbal description, an algebraic generalization, and so on and so on. So there's a lot of material in this lesson today. All right, so let's go ahead and get started. As I mentioned today, we're specifically looking at only the linear parent function. That's it. No other functions are we looking at, just the linear. So the question is, does anybody remember what the equation for that linear parent function is?
Y equals X.
Y equals X. Let's start there. Y equals X. Now, if you notice, the equation says that y is equal to x. In other words, whatever the y value is, the x value is the exact same thing. So if I come over here to the table is going to look like this here. -2, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. That's what the equation says, guys. The equation says that y is the same thing as x. They're equal to each other. So these are the order, or some of the ordered pairs that we have in our table. Of course, we should all remember what the graph looks like. The graph of our linear parent function is this line right here. And of course, when we do this, of course, it should be going through those points that I just wrote down: -2, -2. -1, -1, 0, 0, 1, 1, 2, 2. So you can see that mine's a little bit off here, but you get the idea. Now, the domain and the range. What is the domain and range of our linear parent function? We've also discussed this as well. The domain. What are the x values on this graph here? All real numbers. We can use this notation to describe all real numbers. Range, the y values are exactly the same thing. It's all real numbers. I kind of helped you out on that last question there. It says, what pattern do you observe in the table and graph of the linear parent function? If you look at the table over here, what are we noticing? What do we notice about the x and y values? They're the same. All right, so the x and the y are the same. And they should be the same. That's what the equation says, that y is equal to x. Whatever y is, the x is exactly the same thing. All right, let's keep going here. Let's take a look at some characteristics of our linear functions. Characteristics of linear functions such as slope, the intercepts, and the equations have been addressed in previous math courses. This is what I was mentioning earlier. You guys have already seen this back in Algebra 1. There are 3 different forms of linear equations that you talked about back in Algebra 1. The first one is standard form. What the heck does standard form look like? Anybody remember?
When you break it down, the plus.
Wait,
words.
The y.
Oh,
well,
never
the
mind.
equation's not
I don't know.
y.
You're close.
No,
I know.
it's y equals x.
That's not y equals mx plus b. That's another one. We're going to talk about that one in a second. But I want standard.
Standard is like when, oh no, that's when.
They're not.
Okay. Remember, guys, I said we talked about this back in Algebra 1. If you look at the Algebra 1 word wall over there, notice standard form. It's up there. What does it say over there? Standard form is ax plus by equals c. That is our standard form. That's what you're going to write for me right here. Ax plus by equals c. So if you ever forget it again, you can look right over there on the word wall, and it's there for you. By the way, you'll notice there's a little note out to the side. When you're working with standard form, back in Algebra 1, you're told that you cannot have any fractions in this form, and that the value of a must be a positive number. A has to be a positive number, and no fractions. That is for standard form. The next one is point slope form. Now, this one you didn't use too much back in Algebra 1. You have seen it, you just didn't use it too much. And that one is, trickier here, is y minus y1 is equal to m times x minus x1. This is called our point-slope form. And the reason they call it point-slope form, because within that equation, we have a point, and we also have a slope. Point-slope form. And we're going to use that equation here in a little while. The last one, everybody should know the last one. Slope-intercept form. Slope-intercept form is the one we use the most often. It's the y equals what? Mx plus b. There it is. Y equals mx plus b.
And we saw that one a lot.
Yeah, that one you work with quite a bit. Not only in Algebra 1, but in geometry. And you're also going to work with it quite a bit in here as well. The other two, we see them just not quite as often as the slope-intercept. So these are the three forms of the equation we'll be using today. Now, first one I want to talk about is the slope-intercept form. This is the one you guys have used quite a bit. What we're going to do is we're going to look at two specific things, the slope and the y-intercept. What are some of the changes that are caused by m, the slope? Well, there's a lot, guys, so here we go. We need to get all of this down in that little box that we have provided. So you're going to have to write pretty small to squeeze all that in. So here we go. The first one. The first one says if m is equal to 1. In other words, if your slope is 1, there is no change in the slope of your parent function. No change. In other words, it's going to stay exactly the same. The second one says if m is greater than 0, in other words, if m is a positive number, then the line increases from left to right. If m is greater than 0, in other words, if m is positive, the line increases. Y'all remember that, right? When the slope is positive, the line goes up. When the slope is negative, the line goes down. So that's what this is saying here. When m is greater than 0, the line increases. As a matter of fact, if you look at the next one says if m is less than 0, which means if m is negative, then it decreases. It goes down. And the reason it goes down is because we reflect the line across the x-axis. Remember those transformations we talked about the first 6 weeks? They're going to come back again this second 6 weeks. They'll also come back the third 6 weeks and the fourth. We'll be talking about all those transformations throughout the year. All right, so let's see. The next one says the absolute value of m is greater than 1. When that happens, the slope of the parent function increases. What happens is we get a vertical stretch. There's another one of those transformations that we talked about. So if we have a 2, it stretches a little. If we have a 3, it stretches it a little bit more. If we have a 5, it stretches it even more. So the larger that number is, the more we're stretching it vertically.
Mr. Garcia, do you have Jenna and Salinas?
Yes?
Can you send it up here? She just needs to pick something up right quick and then go back up.
Okay.
Thank you.
And the last one there says negative 1 is less than m is less than 1. In other words, any slope value that's between a negative 1 and a positive 1, excluding 0, except for 0, the slope of the parent function decreases. In other words, we're going to have a vertical compression. We're going to squeeze it down. So it's the same transformation that we discussed back in first 6 weeks that affects our linear parent function. So now what we're going to do is we're going to combine a little bit what we did first 6 weeks with what you did back in Algebra 1. So as you can see here, m does a lot to the graph. Now the b in slope-intercept form it does a few things. Not quite as much as the M does, but it does do a few things here. It says if B is equal to 0, then there's going to be no change in the y-intercept of your parent function. It's going to stay 0, 0. It's going to stay at the origin. If B is greater than 0, then what happens is we have a vertical shift up B units. So if it says plus 5, we move the graph up 5. If it says plus 10, we move the graph up 10. If it says plus 20, we move the graph up 20. That's what that's saying. The last one is just the opposite. The last one says if B is less than 0, then there's a vertical shift down B units. In other words, if it says minus 5, we move down 5. If it says minus 10, we move down 10. It's just like the transformations that we did back in the first 6 weeks. Plus moves the graph up, minus moves the graph down. So I'm not changing the rules on you. Still the same rules. All right, I'm going to go ahead and move on. If you didn't finish, you can go ahead and get it from one of your buddies here. That's one page down, just 7 more to go.
Today?
Okay. We're going to try. I doubt we'll get all 8, but we're going to try.
I can't see.
All right, next one. Finding slope. Finding slope. First of all, what the heck is slope? What do y'all remember about slope in Algebra 1? What did they tell you slope was?
Rate of change.
Rate of change. That's one thing. What else do you know about slope? Rate of change. Come on. You don't remember anything about slope in Algebra 1? Rate of change.
Algebra was so long ago. Oh, where were we?
What? Rise over run. Nobody remembers rise
Somebody
over
said
run?
that.
I didn't hear that. Okay, so we have a couple of things here. We got rate of change. We got rise over run. We can also look at it as the steepness of the line or the slant of the line. So this is what slope is. We're going to look at how do you find the slope given specific situations here in a little bit. All right, so let's see here. How do you find the slope given each of these situations? First of all, if I were to give you this graph here and I ask you, find the slope, how do you find the slope given a graph?
The rise over run.
Rise over run. Come over here and write that down. Rise over run. So let's go ahead and find the slope of this given line. I want to find the rise over run. I want to find out how much it takes to get from one point to another. So to go from this blue point to the other blue point, notice I have to rise. How many do I have to rise? 4. But I also have to run. How many do I have to run? 2. So my slope here is 4 over 2. However, just like with any other fraction, you always want to reduce it. So what does that reduce to? 4 over 2 is the same thing as 2. 4 divided by 2 is 2. Therefore, the slope of this line is 2. So that's what we do if we're given a graph. What if I give you a table? How would you find the slope if I gave you this table here? What's that? I didn't think about that, but yep, you could. You could plot the points in, find the slope that way. But what if we don't have no graph paper?
Can you apply 2 times y1?
Man, now you're getting fancy. I like it. Now, actually, that is true, but we're going to use that one for this one over here. He was saying y2 minus y1 divided by x2 minus 7. Does that look familiar to anybody?
Yeah.
So we're going to use that when we have 2 points.
Is that y1 minus y2?
y2 minus y1 divided by x2 minus x1. And we will be using that here in a second, but we're going to use it when we have 2 points. Over here I have a table. There's a little shortcut, guys, on your calculator. Anybody remember how to use the calculator to find the... Here we go. Now we're talking stats. We got a button on our calculator called the stat button. Let's go ahead and do that real quick. Everybody go to your calculator and go to stats. And then you're going to go to edit. Stat, and then edit. Now, in case you forgot, in stat edit, what are we going to put in L1? The x's, which in this case are 2, 4, and 7. Underneath L2, what do we put in L2? Y. The y values, the 5, the 19, and the 40. Now, once you have all those values in, what are you going to need to do next?
Stat.
Then stat again.
Line reg.
Okay, before you can get there, you got to move to the right where it says count. Right where it says count. Then you're going to use number 4 that says line rate, linear regression. Now it's going to give you 2 numbers, and right now we don't need both of the numbers, we just need the first one, because it's the one that represents the slope. And what is that slope? 7. So the slope given these points, or given this table, is 7. And we did that simply by using the calculator and the stat button.
We go to line reg.
Line rate, yep, number 4. Now, unfortunately, not all of us have one of these fancy calculators to use that stat linear regression. So what if we're working at home and I want to find the slope? Well, that's where this little formula comes in. This is how we find the slope given 2 points. And all this says is we subtract the y values and divide it by subtracting the x values. So let's go and see how this works here. I'm going to use the 2 points that they gave me, -1, 3, and 4, -5. First thing it says is to take your y values and subtract them. Take the second y, subtract the first y. So let me do that. -5 minus 3. Second y minus the first y. What is -5 minus 3? -8. I'm going to do the same thing with the x's now. Take the second x, that's 4, subtract the first x, which is -1. So what is a -4 minus a -1? Oh yeah, it's an equal sign. Yeah, my bad. That's 4 minus a -1. What's 4 minus a -1? 4 minus a -1.
3.
5.
5. That is correct.
Oh, yeah.
+5. Now notice we have a slope of -8 over 5. Can that be reduced? No. So in this case, we will leave it just like it is. Since you can't reduce it, just leave it. Now the final thing we have there is the equations. What if I ask you for the slope and you have an equation? How do you find the slope? Well, let's take a look at the first one, A. Anybody know what the slope would be on that first equation? How do you know that? Because it's in front of the x. Very good. What about B? What would the slope on B be?
2 over 3.
2 over 3. How'd you know that?
Because it's in front of you.
Because it's in front of the x. So I guess that means C, the slope is 3, right? But I thought you said it's in front of the x. Very good. Before you can say in front of the x, it's got to be in slope-intercept form first. Now, this one's not too bad because all we got to do is take 3x and move it to the other side. So, let's do that real quick. So all I did was subtract 3x so that I could have it in slope-intercept form. Now that I have it in slope-intercept form, now you should be able to tell me what the slope is. And that slope is -3. So your slope is in front of the x as long as you're talking slope-intercept form. So what I've just gone over here today, so far, you guys have seen this back in algebra 1, right?
Yes.
Maybe you didn't remember off the top of your head, but it's coming back, right? It's coming back. Now let's talk about intercepts. We talked about slope. Now let's talk about intercepts. What are intercepts? What are they? Well, all it is where a line or a graph, doesn't have to be a line, it could be anything, intersects or crosses the x or y axis. Now, since we're talking lines here, most of the time, not all the time, but most of the time, you're going to have an x-intercept and a y-intercept. Most of the time. There are occasions here and there where maybe you just have one. Maybe you just have an x-intercept. Maybe you just have a y-intercept. But that doesn't happen too often. Usually you have two. Usually. All right, so explain how you find the y-intercept. Circle that part for me right there. Y-intercept. How would you find the y-intercept in each of these cases here? All right, let's start with a graph. If I gave you a graph, and I were to ask you, what is the y-intercept? What exactly would you be looking for? There it is. Determine where the line would cross the y-axis. That's why they call it the y-intercept. Because we're looking for where does it cross the y-axis.
That's what.
Y-axis. But what if instead of giving you a graph, I gave you a table instead? How would you find the y-intercept if I gave you a table? You're looking for what point? There you go. You're looking for 0 something. You're looking for an ordered pair that looks like 0 something.
What is the other thing?
What other thing?
Oh my God, I can't see.
So that's what we do if we have a table. We're looking for an ordered pair that has an x value of 0 and the y value could be in it. The next one, what if I give you an equation in slope-intercept form? Where am I going to find the y-intercept? It's the b. Whatever the b is, represents the y-intercept. Whatever your b is, represents the y-intercept. Now the last one there says from any equation. So what if I have some generic equation where it's not in slope-intercept form, and I want to find the y-intercept? It says here that we're going to plug in blank and then solve for blank. Well, remember, the ordered pair we said earlier was this right here. We're looking for 0 something. So the y-intercept is always going to be 0 something. So what we're going to do is we're going to plug in 0 for x, plug in 0 for the x, and then you're going to be solving for y. So we're going to plug in 0 for the x and then solve for y. So remember, this is to find the y-intercepts. It's a little bit different. It's a little bit different when you're looking for the x-intercepts. So now we're looking at x-intercepts, not y-intercepts, x-intercepts. So the first one says if we have a graph, how would you find the x-intercept? What are you looking for? Where the line crosses the x-axis. You're looking for where the line crosses the x-axis. If you have a table, now the last one we said we were looking for the ordered pair 0 something. Now we're looking for what? Something 0, right? So in the table you'll be looking for the ordered pair something 0. And then finally, if we have an equation, how would you find the x-intercept given an equation? It's just the opposite of the last one. What we do is we plug in 0 for the y, and then solve for x.
That's 3 plus x.
Yes.
Jesus, you were blind.
All right, sounds like you guys are still with me here. Okay, let's keep going here. Going on to the next page. Here it says there are several ways to determine the equation of a line depending on what you are given. So, a big portion of your assignment today and a big portion of that test that we got coming up next week is going to revolve around this next part here. So it's very important that we pay attention to this next part. It says that if you have this information, then plug in values into what? So here we go. if you have the slope and you have the y-intercept, which of the three equations that I gave you earlier would best suit this information? Y equals mx plus b. It's called the slope-intercept form. So if you're given a slope and you're also given a y-intercept, the first thing you should be thinking is slope-intercept form. Because all you'd have to do is replace m with the slope and replace b with the y-intercept. The next one. What if I give you a slope and I also give you a point? If I give you a point and a slope, which of those three equations that I mentioned earlier would work best for this information? A point and a slope. Point, slope, form.
Yeah.
Point, slope, form. Anytime you have a point and a slope, you should be thinking point, slope, form. And I'm going to show you how to use this point, slope, form here in a minute. I know for some of you, that's like Chinese. You have no idea what the heck that is. And we're going to look at that here in a minute. The next one says the coordinates of 2 points. So what if I just give you 2 ordered pairs and I say, give me an equation? I don't know what to do. But? Huh? Say that again. And what is that going to help us do? Find the slope. Okay, so what I would do here is first use the equation or the expression y2 minus y1 divided by x2 minus x. This is going to help us find the slope. That's what this first part is. Find the slope using this little thing right here. Once you have that slope, then you can move on and use the point slope form. Because at that point you would have a slope and you would also have a point, which means you could use the point slope form. And then the last one, what if we have a table of data? I think, Claudia, you mentioned this one earlier. What do you do here? What's that? Well, we could write it in standard form, but I'm talking about how would we actually get the equation. In this case, using your calculator and that stat button, do a linear regression. Okay? So if we have a table of data, the easiest thing to do would be to go ahead and do a linear regression on our calculator. Now, like I mentioned earlier, unfortunately, sometimes we're at home, we're doing homework, and we don't have this calculator to do a linear regression. So we would have to do another method. And probably the one right above it would be the best. Find the slope, use the point slope. All right, so these are some quick notes here. We're going to be looking at some examples of each of these here in a little bit. We want to make sure we understand when to use which of the equations. Any questions so far? I know I'm throwing a lot at you guys, but it's a lot of material we got to get through, and a lot of this should just be reviewed. Special lines and slopes. Here's some other things that you should already know. Horizontal line. Of course, horizontal line is the line that goes across. What is the slope of a horizontal line? Zero. Zero. The slope of a horizontal line is 0. And you can just put n equals 0. That's good enough. Horizontal line has a slope of 0. Let me give you an example of an equation that has a 0 slope. Here's an example. Y equals some number. It could be any number. It could be y equals 3. It could be y equals 5. It could be y equals 20. So anytime we have a horizontal line, you're going to notice there is no x in the equation. It's just a y. A vertical line is just the opposite. A vertical line is a line that goes up and down. Anybody know what kind of slope you have for a line that goes up and down?
Undefined.
Undefined. It's an undefined slope. So I'm going to give you an equation that would have an undefined slope, or a vertical line. It's the opposite of this first one. Instead of y equals a number, this one's going to be x equals my number. X equals 5. That would be a vertical line. X equals 20. That would be a vertical line. So notice on this one, there is no y dot. It's just the x. Just the x. All right. Parallel lines. Last year, most of you guys were in geometry. What do you know about parallel lines? They never touch. Very good. They never touch. Now, in order for those lines to never touch, what has to be true about their slopes? Not reciprocals, the same. They're exactly the same. Otherwise, they wouldn't be parallel. So what I have here is that M1, which is the slope of the first one, has to equal M2, or the slope of the second line. So the slopes have to be identical. They have to be exactly the same. Otherwise, somewhere down the line, they will end up intersecting, crossing.
So,
And I'm going to give you an example of two lines that are parallel. Here's an example. Y equals 2x plus 3, and y equals 2x minus 7. Those are examples of parallel lines. Why? How do I know that they're parallel? Because I'm looking at their slopes. And because those two numbers are the same, we know they're going to be parallel. As long as they're exactly the same, you would have parallel lines. Perpendicular lines from geometry. Remember anything about perpendicular lines? What do those look like?
they intersect.
They intersect. Yes, they do intersect. But would this be perpendicular? No. There you go. They have to form a 90-degree angle. What do we know about our slopes? If we want to have that 90-degree angle, have to be opposite. Something else. You're half right. Huh? One. Okay, that's the same thing. Opposite meaning one has to be negative, the other has to be positive. But what else? There's one other thing. You're half right. The slopes have to be what we call opposite reciprocals. Opposite reciprocals. Now, we've already said what the opposite part means. Opposite meaning one has to be positive, the other one has to be negative. One line has to go up, the other line has to go down. But not only that, they also have to be reciprocals. Now, what do I mean when I say reciprocals? Well, since slopes are fractions, guys, that fraction, when we're talking reciprocal, means that we're taking the fraction and doing what to it? Flipping it. That's what reciprocal is. We're flipping the fraction upside down. So let me show you an example of what that's going to look like. Here's an example. Y equals 2x plus 3, and y equals negative 1/2 x minus 7. These are perpendicular lines. And how do I know that? Because I'm looking right here at the slopes. Notice how one is positive, the other is negative. That's the opposite part. Notice they're also reciprocals of each other. In other words, the first slope is 2, which could also be written as 2 over 1. And what would you get if you take 2 over 1 and flip it upside down? You get 1 over 2. So that's the reciprocal part. So the only way they can be perpendicular if they're opposite reciprocals. So let me throw this one at you. If I gave you this equation, and I said, I want a line that's perpendicular to this line right here. What does the slope have to be?
Positive.
Well, it has to be opposite of a negative, which is a positive. And it's going to be a positive number. Then we take the fraction and flip it upside down, which would make it 3 over 2. So here's another example of opposite reciprocals. That's what gives us perpendicular lines. All right, that's a lot of notes. Now we're going to look specifically at some examples now. Here are some samples. They provide us with some information, and we're going to have to fill out the rest. Now, all they gave me on this first one here is this line. And from that line, I've got to come up with a table. I've got to find the slope. I've got to come up with an equation. And I also have to find the y-intercepts. So let's start with the table. What I want to know, well, what are some points that are on this line? Give me some points that are on that line, guys.
0, 5.
0, 5. All right, so 0, 5. Are you sure? 0, 5 would be up here.
I mean 0, -5.
There you go. 0, -5 would be this point here.
1, 3.
There's other points, like, what was that? 1, 1,
0.
1, -3.
negative.
Oh, -3.
Negative.
Oh, you did this.
Okay. What else?
2, -1.
2, negative
No.
1.
Yes.
One more.
3, 1.
3, 1.
3, 1.
3, 1. Now what we've just done is we've just listed 4 points. Are those the only 4 points on this line?
No.
No, there's a lot of others that we could have listed. We just mentioned these 4. All right, now let's go ahead and determine the slope. What is the slope of this line here?
2 over 1. Or just 2.
2 over 1 or just 2? How did you get that 2? Rise over run. To get from one point to another point, notice I had to go up 2 and over 1. Up 2 and over 1. That's our slope. Next thing I'm looking for is the equation of this line. And we're going to write that equation in slope-intercept form. We've already got half of it, guys. We already know what the slope is. We just said that it was
2.
2. So we know it's y equals 2x. Minus what?
5.
5. And where's that minus 5 coming from?
Y intercept.
It's the y-intercept. It's this point right here. There's your equation for this line. Finally, what we need is the y and the x-intercepts. Let me start with the y-intercept because we already have that one written down. What is the y-intercept on this?
0, -5.
0, -5. Again, it's this point right here. 0, -5. Now, it's a little bit trickier to find the x-intercept. What is that x-intercept?
2.5.
Well, but I want it as an order pairing. Order pairing.
Oh, so you're being picky.
Yep.
0, 2.5.
Oh,
Oh,
no,
2.5, 0.
There you go. 2.5. Oh, what happened to my ink here? Dry. I ran out of ink.
Seriously?
There it is. Now, how do we know for certain that it's 2.5? How do you know it's not 2.49? Huh? You did it in the calculator? Is there another way we could have done this without using our calculator? Or we don't have to?
0 over 9 intercept. We could have done the
We wrote it in our notes.
all of these stat. The y2, y1.
Point slope
3,
one?
4.
One slope? No. Guys, if I want to find the x-intercept, I tell you what, let's go back over here. No. If I want to find the x-intercept, there it is. If I want to find the x-intercept, if I'm given a graph, I can find where it crosses the x-axis, which we said looked like 2.5. If I have a table, I can look for the order pair something 0. But look at the last one. What if I have an equation? It says here that I can plug in 0 for the y and then solve for the x. All right? Now, in this particular case, that's probably the route that I would go. It is very hard to make sure, just looking at that it is 2.5. I'm just going to show you real quick how that works. So again, it said take the 0 or plug in 0 for y and then solve for x. So I'm just double checking to make sure it is in fact 2.5. So let's solve for x. First thing I do is add 5. So now that 5 is equal to 2x. I'm solving for x, so the next thing I do is divide by 2. And what do you get when you do 5 divided by 2? 2.5. Exactly what we said over here. So again, I'm just double checking to make sure that it's not maybe 2.4, maybe 2.6. All right, so that's number 1. Let's go to the next, a little bit different. A little bit different. On this one, they didn't give me the graph. What they gave me instead was a table. And from this table, I got to come up with all this other information. And so let me start with the graph. Let's go ahead and plot these points to come up with the graph. Let's find -1, 10. -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. There's one negative 10. Now I'm looking for one positive 4. 1, 2, 3, 4. There's one positive 4. Now let's find 3 negative 2. Here's my 3. Here's my negative 2. The last point is 5 negative 8. So let me find 5 negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There it is. At this point, I have the 4 points plotted. Now I'm going to come over here and connect those dots. And there's my line. Part B asks us to find the slope of that line. What is the slope of that line? Well, let's count. If I want to get from one point to another, first I've got to go down how many? 1, 2, 3, 4, 5, 6. So we're going down 6. Now keep in mind, since I went down, that's negative. But I'm also having to move over, run 2. So I've got negative 6 over 2 as my slope. However, we can reduce that. Negative 6 divided by 2 is the equivalent of a 3. Negative 3. So your slope for this line is negative 3. Now let's find the equation of that line. You're halfway there already because you've already found the slope. You said it was negative 3. So the first part of the equation is y equals negative 3x. All we have to do is find the y-intercept. Anybody think they know what the y-intercept is? Now notice here, when I drew my line, guys, I wasn't extremely accurate here. If I had a ruler or something, maybe I could do a little better job of drawing my line. However, what I could have done is now, since I know the slope is negative 3, I can continue with that pattern. So notice if I start up here, notice what happens if I go down 3 and over 1. Down 3, over 1. Down 3, over 1. Down 3, over 1. Notice it's the same pattern that we have with the other points. Now it's just the more dots we have, the more accurate the line's going to be. So now I can definitely see the y-intercept. And that y-intercept is what now? 1, 2, 3, 4, 5, 6, 7. So it's y equals negative 3x plus 7. So if you know your slope, go ahead and use it. And finally, let's go ahead and find the x and y intercepts. Now the y-intercept, we just said it was 7. We're just going to write it as an ordered pair. And that ordered pair would be 0, 7. The one that's going to be a little trickier here is finding the x-intercept. And I'm going to go ahead and do it the same way that I just showed you. I'm going to replace y with 0. And I'm going to solve for x in the equation. Here we go. We're solving for x. First, I'm going to subtract 7. So I've got negative 7 is equal to negative 3x. I'm solving for x, so the next thing I'm going to do is divide by negative 3. So the question is, what is negative 7 divided by negative 3? Negative what? No, not negative though, right? Should be positive 2.3. 3, just 3?
Well, there's like a bunch of
3. So it's 2.333 or 2 1/3. Now remember, we're writing this as an ordered pair. So we're talking 2.333. So notice I'm very accurate here. I didn't just go and say, that looks like 2.5. I'm very accurate with my x-intercept. All right, guys, we're going to go ahead and stop right there. We'll pick up there tomorrow.